In this video, we're going to see how to figure out how to change the order of integration in an iterated integral. So what we're going to want to do is take this integral here, which you can see is missing a function, or it appears to be, but that's because the function we're integrating is actually just 1. And what we want to do is figure out the limits of integration that we'd be using if the order of integration was reversed, if we had dx dy instead of dy dx. So the way we're going to go about doing that is we're going to look at the integral, the iterated integral on the left, and we're going to try to figure out what region is being described there. Now, the way I would start with this is to indicate what the limits, which variable the limits of integration are. So the outer limits are for the variable x, and the inner limits are for the variable y. So let's take this equation, the only one that's really an equation involving x and y, which would be y equals 4 minus x squared. And let's graph that. Okay, so let's see. We know because it's got an x squared in it, it's a parabola. It's a parabola opening downward. And if it was just y equals negative x squared, it would be the parabola that would look like this one I'm drawing in green. But that 4 ends up shifting the whole parabola up by 4 units. So the parabola looks something like this. It's like the blue parabola here, which would be y equals 4 minus x squared. And of course, when x is 0, y is 4, so the height here would be 4. And we'd like to figure out where it's crossing this axis. That axis is where, that's an x-intercept, which is where y equals 0. And to get y equal to 0, we'd need x to be either 2 or negative 2. So that's at 2 right there and negative 2 over here. Okay, so that's that part of the picture, the y equals 4 minus x squared. The other y limit is y equals 4, which is simply a horizontal line at height 4. So there's the y equals 4. And so we're looking at those two graphs, and our x is restricted to be between 0 and 2. So we're in, I'm going to mark those off with some vertical red lines. So we're in there between 0 and 2. And so we've got to be between these two red lines. And we've got to be between the parabola, y equals 4 minus x squared, and the horizontal line, y equals 4. So that puts us in this region that I'm shading in red. So there's the region we're interested in. So now if we go and try to put our limits in our other integral, we first need to put some outer limits for y. And you can see that y runs from 0 to 4. And then we need to get our x limits. If we fix any particular y and run through our shape, you can see that we enter here on the y equals 4 minus x squared. Okay, so we'll enter on that curve, but we're going to need to solve that for x. So let's come back and do that in a moment. But we leave here, which is where x equals 2. So let's go ahead and put that in up here. That's x equals 2. So we need the x for that parabola. If we go back over here to the left where we had these things, if I was to add x squared to both sides, I'd have x squared plus y equals 4. I'll subtract y from both sides. I get x squared equals 4 minus y. And so x we get by square rooting both sides. So it's the square root of 4 minus y, but we need a plus or minus. However, we're only interested in the part of the parabola where x is positive, so we can just ignore the negative version of that. And we have x equals 4 minus y. So that's our lower limit in x is square root 4 minus y. So that's how we do this. Let's go to our next example here. And so let's see, I already had one written. There we go. So for this example, what I'd like you to do is why don't you pause the video and try the same process we did on the other one, and then go ahead and start it again when you're finished or when you get stuck. Okay, so here we go with this one. Let's go ahead and decide which variables are the limits of integration. So we can see in here, these are the x variables, and these are the y variables on the outer integral. So I'm going to put an equals x up here on this guy. And so the only thing there that's actually an equation involving both x and y is the one I've circled in green. So let me bring it down here and write that down. And I'm going to need to graph that, but I don't recognize this form, or I recognize it as being a line, but not in such a way that I'm able to draw the graph. So I'm going to solve for y. I have negative 2y equals x minus 4. And we'll divide by negative 2 on both sides. And so we get y equals x over negative 2 plus negative 4 over negative 2. Okay, so we have y equals, I'm going to pull the x off of there, that's negative 1/2 x plus 2. Okay, so there's our equation when we've solved for y. So let's go ahead and graph that. That's a line with a y-intercept of 2. So there's 2. And an x-intercept of 4. So let me actually draw the line in blue. So there's the line. It has two equations that we've got here. It's y equals negative 1/2 x plus 2. And it's also x equals 4 minus 2y. Okay, so there's the line. And if we look at our integrals, our y goes from 0 to 2. So we're in this swath for y. And within there, our x goes from 0, so that's along here where x is 0, over to the line that we just graphed. So this triangle is the region that we're talking about. So now when we go to do the integral in the opposite order, now we're going to have x equals here, y equals here. We're still integrating 1. We'll have dy because that's got to match with the inner integral, and then dx there. Okay, so you can see that if we look at our region we've shaded in there, the x goes from 0 to 4. And then for each value of x, as we pass through the region, like this, we always enter along the x-axis, which is where y equals 0, and we leave at the line that we graphed, which is y equals negative 1/2 x plus 2. So that concludes our video on how to change the order of integration in an iterated integral.